and how it affects perimeter, how it affects area, and how it affects volume. And we've done this gazillions of times, and it takes probably a gazillion and one times for you actually to catch on to this. In other words, this. Let's say you have, well, we always talk about a pizza. Let's do it. Let's do a rectangular pizza just because it's better. Let's say you've got a rectangular pizza. Well, that's not the one I want to start with. Let's say I start with the rectangular pizza up here. And that pizza, what, Jake, a regular sized pizza maybe is how many inches by how many inches? Maybe we should use centimeters.
I don't know, like 2 inches, 3 inches.
Oh, let's go, let's say this pizza started out being 3 inches by 5 inches. That's your personal pizza. After you go to the store, you get personal pizza. Yeah. Okay. 2 inches would be like a breadstick.
No size.
Okay. What happens when you double the size of that pizza? Now let's figure it out when it's just a normal pizza. Here's my normal pizza. Please stop. It's 3 by 5. What is its perimeter? And I don't expect the whole math. You should be able to figure that out without, what is the perimeter there? You can add all that in your head. Grace, it's 16 inches. What is its area? 3 by 5, that means its area is, Gary?
15 inches squared.
15 inches squared. It's pretty hard to have the volume of a pizza. But let's make this pizza 1 inch thick. Just because. Let's draw 3-dimensional, that'll make it look better. Jake, what toppings did you say you wanted on? What, pepperoni?
Yeah,
It's one of
pepperoni,
them cheesy, goofy things.
bacon.
Oh, bacon.
Yeah,
Strips of bacon, not just bacon bits.
some pineapple.
So let's say this is 1 by 5 by 3. What's its volume? 1 times 5 times 3, the volume of this pizza is 15 inches cubed. Now, what we're looking at is what happens to these 3 different measurements if I double that pizza. If I double the dimensions of that pizza. Okay? So if this pizza is no longer 3 by 5, but I double each one of those, it is now what? 6 by 10, correct? Stop me there if I'm wrong. I'm doubling the pizza. What happens to the perimeter? Well, the perimeter of the new pizza is what? 10 plus 6 plus 10 plus 6 is 32 inches. What happened to the perimeter when I doubled the dimensions? It doubled. It's whatever you did to it is what happened. I got 32 inches, which makes sense. That is the logical part. Okay? That's what you would expect to happen. But what about the volume? The volume of my new pizza, the area of my new pizza, my 6 by 10 pizza is 60 inches squared, which is not doubling. It's actually, to go from 15 to 16, you have to do what? Quadruple, or times 4. And in my volume, if I double all those dimensions there, I get a 2-inch high thing by 10 inches. Don't have enough room. By what? 6 inches. This is 6 by 10 by 2. My new volume is, what is 60 times 2? 120 inches cubed. Now I don't know, what is, to go from 15 to 120, anybody? Kelvin?
Wouldn't that be times 8?
It is times 8. It's 8 times bigger. So now that's not logical to you. Because usually we think if we double something's dimensions, its volume is going to be doubled. But I can tell you no. If you went to a store and and you had a pizza that was this size, and then they said, well, this is twice the dimensions of it, this pizza actually is has 8 times more, whatever, volume to it. It's like having 8 of these pizzas. When you started with this pizza, when you started with this pizza and you ended up with that pizza, it's like having 8 of them. This one was $10, you should pay $80 for that one. Now why is that? Why is that? Why is the perimeter only the same as dimensions? That's because when you find perimeter, what are you doing? You're just adding. Okay, and adding doesn't really change whatever the numbers are. But this one, I am multiplying. And what happens when I multiply? To go from 3 to 6, I multiplied that by 2, correct? And to go from 5 to 10, I multiplied that by 2. What is 2 times 2? 4. That's why it was 4 times bigger. This one, I doubled the 1, I doubled the 5, I doubled the 3, which means I have 3 2's multiplied by 2 3 times, that is 8 times bigger. And as you are starting to lose this here, what would happen if I tripled the dimensions? If this, well, this one's going to be tripled. It's going to be the same. Okay, the dimensions here, if this is 3 times bigger, then this is going to be 3 times bigger for perimeter. It stays the same since it's only adding. This one, though, I get my new dimensions to be 9 by 15. My new thing is 9 by 15. Guess how much bigger the area is going to be? Now remember what you did, to go from 3 to 9 is you multiplied by 3, and to go from 5 to 15 you multiplied by 3. 3 times 3 is, this one will be 9 times bigger than your starting thing. Okay? And I know, here's the gist of that, as you stare off into somebody's whatever space. So let me get a new page here. Here's what you have to understand. With scaling, write this down because this is all you need to know. Whoa, when did that happen? It just happened. With scaling, here is your thing. Your handy dandy to do. Okay? You first of all, you need to find what the scale factor is. Okay. Find the scale factor. And let's talk about that just for a second here. Let's say I have a circle that started out being 2 inches in diameter, and then I drew a new circle that is, 2 inches in radius, was 4 inches in radius. Okay. The 3 things we're going to look at are, how does that change its perimeter, which in the circle's case is called its circumference. How does that change its area? And I guess we can't really talk about volume because I didn't give it any volume. I probably should though. Can I give it volume? This is twice as big. Here is your handy dandy guide. The first thing you have to do is find the scale factor. In other words, this. How do you go from 2 to 4? What do you multiply by? Times 2. So the scale factor, the scale factor is 2. Okay? If the scale factor is 2, then the perimeter will also be 2 times bigger. The area, here's where it gets a little goofy, is the scale factor squared times bigger. So if the scale factor was 2, what is 2 squared? 4. The area of this one will be 4 times the area of that one. And the volume is the scale factor cubed times bigger. In other words, the volume of this next one will not be is 2 times bigger, but it's 2 cubed. What is 2 cubed? 8 times bigger. It's not necessarily something you think of logically. Let me give you this. Maybe if we walk through some problems, it'll help you. And maybe it won't. Maybe you'll end up less confused than you were. What is on the back of that?
A, B, C.
All right, I'm just gonna give you the first sheet of this. Because we need to talk about this, because many of you are staring off into the headlights. Emily, either pick a number between A and B. Ah, which is what? B. Let's look at letter B. Look at letter B with me. If I ever get around to your letter B. Look at letter B. Read letter D to yourself and it's aloud. Letter D. Everybody has a letter D? Okay, look at letter D. Letter D says, find the scale factor of the small rectangle to the large rectangle. Find the ratios of the perimeter and the areas of the large rectangle to the small rectangle. Here you go. So here's letter D, children. You've got the big rectangle, which is what? Does it give us the other one? Oh yeah, here we go. Sorry. You've got this rectangle and this rectangle. This is 4 by 2. This one is 6 inches here, right? Here we go. So here's what you think. What is my scale factor? How many times bigger is the big rectangle than the small one? To do that, you look at this. Okay, I know what this side is. This is the short side. This is the short side. The scale factor is what you multiply this by to get that. My scale factor is what? 3 times bigger. That's my scale factor. From the small to the big, you multiply by 3. So I can tell you what's the length of this side going to be? You just take, this is 4, so times 3, this is going to be 12 inches. Okay? So is that the first question they asked? Find the ratios of the perimeters and the area of the larger to the smaller. Well, the perimeter doesn't change. The ratio of the perimeter, how much bigger is the perimeter? Right here. The perimeter is going to be the same. I mean, the same as the scale factor. We can do it out. Let's do, what is the ratio of the small one? Or what is the perimeter of the small rectangle? Small rectangle's perimeter is? Small one is 12. Where do I write that? This is 12. Perimeter of the big one is? 12 plus 12 plus 6 plus 6 is 36. The ratio of the big one, 36, to the small one, which is 12, is what? 36 over 12 is 3. There's your ratio. Right? What about the area? What's the area of the small one? 2 times 4 is 8. 12 times 6 is 72. So the ratio of the big one was 72, the small one was 8. What is its ratio of 72 divided by 8? 9. The scale factor was 3. If you're looking at area, what do you do to the scale factor? You square it. 3 times 3 is 9. That's why this one was 9 times bigger. Physical eyes.
This was in a drawing by computer lab.
Yes, I believe that is Ryan's. Ryan, are those your goggles? He said no. I didn't know. I had no idea. I didn't have them there. I think Mrs. Stone did it. Alright, kids, here you go. Mesmerized you are. Look at letter B. This isn't so bad if you draw it out and think about it. The dimensions of a wallet-sized photo are about half the dimensions of a 5x7 photo. The area of a wallet-sized photo is about what fraction of the area of a 5x7 photo? So Smith says, you know what I'm going to do? I'm going to draw that out. Correct? Okay. And I have a what size photo? A 5x7. A wallet-sized one is about half of that, which means it would be like it's 2 by 3.5, 2.5 by 3.5. Now, you don't need to do any real, Evan, what's the name? 2.5 by 3.5, sorry. You can't see that. You don't really need to do all the calculation if you can just figure out what the scale factor is. What is my scale factor from the big one to the small one? What did it say? It told you what the scale factor was. It is, Christine? Half. My scale factor is 1/2. Okay? Now, if I was talking about the perimeter of these two things, the perimeter of this will be half of that, because perimeter is the same as scale factor. If I'm talking about area, though, area is the scale factor squared. So if you know the scale factor, you just plug that in there. What is 1/2 squared? 1/4. This small picture will be 1/4 the size of that big picture. That's all you need to know. You don't have to do the whole calculating the whole thing and make it a fraction. You just know that's true. Ah, that was exciting. One more. Which one would you say would be a good one? Oh, letter H. A 6-inch diameter balloon holds a pint of water. How much water does a 6-inch radius balloon hold? Now, the first thing you have to understand is this. Well, let's draw a picture first. What was this? 6-inch diameter was first. And then the next one was a 6-inch, let's just pretend it was this 6-inch radius there. Now, when you talk about water, when you talk about pints, is that like perimeter, is that like area, or is that like volume? When you have a gallon of water, is that the area of the water, or is that the volume of the water? Volume. So automatically you think this. Volume is the scale factor what? Cubed. Okay? So if you can figure out what the scale factor is from this one to this one, you just need to cube it, and that's how much more water this will hold than that one. What is the scale factor of this one? Well, the diameter was 6 inches, the diameter is 12 inches, so my scale factor is times 2. So the volume is times 2 cubed. What is 2 times 2 times 2? 8. So the volume of this one is 8 times bigger. It'll hold 8 times as much water, which means it'll hold how much water? If it went from a pint, was it a pint? How much water does the bigger one hold? 8 pints. Smith, how much is 8 pints? 8 pints is how many quarts is how many gallons? Oh, there's Mr. Gallon over there. Sammy, 8 pints is 4 quarts. 4 quarts is 1 gallon. I don't know if that made any sense to you or not. I'm really trying. We'll stop there. All right.